All right, we have the little voice that tells us that. Again, my name is Dan Hendy from the Maintenance Institute. You're here at our Facilities Operations and Maintenance Learning Network, and we have a special guest today, which is Douglas Hout, who's the manager of public safety for PA, Rhode Island, and Kentucky of PPL, and he's going to talk about all things electricity wise and maybe some of the do's and don'ts and what happens when you do come across um, circumstances in your facilities or in your public spaces. And with further ado, I'm going to turn it over to you, Doug.
All right. Thank you, Dan. Good afternoon, everybody. Thanks for Dan inviting PPL to join your learning session here today. Again, I am with PPL Electric Utilities, which we cover 29 counties in eastern and central Pennsylvania. So I understand in talking with Dan, some of you may be outside of our service territory, possibly working near facilities by an entity of First Energy, Duquesne, or potentially even the Pico area. So I'll talk on a high level here because our facilities based on PPL, First Energy, Pico, Duquesne, we're all slightly different. And so, I would just want you to consult with your electric provider if you have specific questions, for that utility. So we consider you folks first responders, and that's because when storms come through, you potentially have that job to get out within your facilities to try to, make the situation safe. And what this is about is to understand the electric facilities and understand that you have nothing in your possession that would allow you to touch any wire that comes down until you get confirmation from your utility that the line is out and the line is grounded. That is the only time it is safe for you to touch any type of wire. And we say any type because as we walk through here, communication lines, phone fiber, right? A lot of fiber getting put up. And those wires, if they do come in contact with an overhead electric line, or the electric line sags into those communication lines and it touches that quarter-inch piece of black wire, that communication wire can carry the voltage in that line if the energized wire is touching that cable wire. So that's the importance of understanding you have nothing that allows you to touch any type of wire that comes down until you get confirmation from your utility. Well, then it worked initially. Let's see here. Now it's not allowing me to advance my slide. Oh, there we go. Okay. All right. So staying safe, essentially, while potentially helping others or even saving others, depending on the situation that's out there. So just a little bit about the electrical grid. So we get power plants out there. And for us, this is actually one of our what was PPL's in our Washingtonville area. Those generate anywhere from 23 volts or higher, depending, coming out of a generator. And then they come out to these larger transformers that are outside that generation plant. And for us, we step voltage up outside of that power plant. And for us, we step it up to high voltages of 230,000 volts to 500,000 volts. And again, each utility is slightly different, but it's not the volts that we need to be concerned about. It's the amps that are in the line. And when you're at 230 and 500 kilovolt, there are thousands and thousands of amps. We then take that energy, transport it over the very tall lattice, and now we're going to steel monopole structures that range anywhere from 80 feet to 200 feet in the air. We take that to what we call a transmission substation, where we now need to get to start bringing the voltage down so that we can ultimately get it to our customer to use. So we step down to 69,000 and 138,000, transport it one more time to what we call an area supply substation. So these are the substations that are out within the communities. At that sub, we are taking generally 69,000 and we're stepping it down one more time to what we call three-phase 12,500 volts. And those are the lines that run out within the communities and through the park services. Generally, I'm thinking you're going to get single phase, so that's one wire up on top of that pole, and for us that carries 7,200 volts of electricity. So again, MedEd, all the First Energy companies, they're slightly different. They're running about 8,400 kV on single phase. But again, it's not that volt that matters. It's the amps that are in the line. And then the transformers that are out there to step it down one more time, right? So to get a high voltage and you continue to step it down. And those are the transformers that are on the poles, the small poles, wood poles that are within the parks and the park and rec facilities. So you got an overhead transformer and then you have the underground transformer. Both of these are doing exactly the same thing. For us today, so you know, it's all mineral oil inside of these transformers. All the old transformers with the PCB oils of the old days have been pretty much removed. So just how we get it from a power plant down to our customers and ultimately the Parks and Rec folks. Many different devices out there on the poles. We got to be able to control things, and circuit breakers in a sub, a recloser, and then a fuse. And maybe within the parks, these are the fuses that you'll see up on a pole. And it's much like a breaker in your home. If something happens in your home, breaker trips. And for us out here on the line, these devices actually trip. Tree comes down on it, and you get this fuse that blows up here. This is three-phase. This is what we call a Viper. Again, all doing the same type of thing. Shutting off the power just because those devices have operated. One thing that we still find today, no matter what happens, if it's a storm, you have got to always consider, if you see this throttle hanging like it is in this position here, which cuts and opens the wire, if you will, and stops the flow of electricity. But still today, we find customers that backfeed our system, and they're backfeeding from a generator. So if a customer hooks up a generator, a standalone generator, wheeled it out of their shed or their garage, brought it over to the side of their home, plug an extension cord in, and they plug that extension cord into an outlet in their home, okay? They must turn the main breaker off inside the home. And trust us, we find it still today, every storm, where a customer does not open the main breaker. And by not opening that main breaker and that extension cord plugged into the generator to an outlet, the energy from that generator bypasses the meter and goes out to that transformer that's on the pole. And that transformer works in the opposite direction. And it will step that energy up from that generator on our system to 7,200 volts. So just because that fuse opened or that Viper operated, it doesn't give you a green light to go move that wire or cut a tree. Please do not cut trees off of wires until your utility is there and told you the line is out and the line is grounded. Okay. And why do we need the grounds? We work between grounds when we are out doing work, and that is to take away generator backfeed. And again, it happens all the time. Okay. Can't stress that enough. Um, just who owns what out there. So everything in red is owned by the utility. Okay. Here's your top wires are energized. So you could have one wire up on top. You could have three wires. You could have two wires up on top. Top wires are the energized wires. You have your fuse, okay, which is protecting the transformer, and this wire is our neutral. A neutral you must consider as energized. It is our return path. If a phase wire comes off the top of the pole and it's away from where that tree maybe is on the wire, it's looking, where does electricity want to go? Electricity wants to go to ground, and it will use the neutral to come back. So you got to consider the neutral or the ground wire and the top wires as energized. And then you have the service wire that comes into the buildings within the park and rec or into your home. Okay, they're all the same, but we own the wire into the point of attachment on the building or on the weatherhead. Everything in green is owned by you folks, the weatherhead and the meter base. We own the meter. Everything below the neutral on the pole is communication. So we cannot have facilities that are below the neutral, and the communication wires cannot be above the neutral on the pole. So it gives you some sense of who owns what, okay? So from the neutral up is electric, from the neutral down the pole becomes communication facilities. Again, just different components out there. The insulators up on top of the pole. The insulator is what stops the flow of electricity. It's what allows us to touch the pole out there. The higher the voltage, the longer and bigger that insulator needs to become to stop the flow of electricity. The cutouts are the fuses and transformers. Here you can see the difference. Okay, we got several different types of insulators. You got a dead end porcelain insulator. We got what's called a ridge pin insulator on single phase. And this one on this side, which is what we are using probably 99% of the time today, and it's a polymer insulator. But they all do the same thing. So you can see the distribution insulators versus this larger string of insulators, that's on a 500 kV line, okay? And that insulator string is about 22 feet long to stop the flow of high voltage out there on the transmission system. So just insulators and what they do. Many different types of wire, okay, out on the system. And one thing I stress and always want to point out, you'll see this black coated wire, okay? And you'll see the bare wire. So you have aluminum ACSR, you got old copper, still a lot of copper out there on the systems, and then this black covering, okay, that's on some of the wire that's out there. Some of it's we actually call tree wire, and the intent is by putting up this tree wire or covered wire, if a tree were to fall, it acts as more of a protection, and it will not trip the line, has the potential to not trip that line. But do not think of this coating as insulation, okay? It's a black coating that's on it to protect a lot of cases. There is a bare neutral that runs with that wire as well. And what it's there for is to protect the hot legs from the bare system neutral. Okay. All it takes is a pinhole in that coating. So you got UV rays, you got animals. How many times do we see the squirrel, right, run out across that wire and they're nibbling on that coating? And if that is the wire that comes down, and in your mind you think that's insulated wire, I got a pair of gloves on, we can just move that wire. But if that wire is still energized and there is a pinhole in that coating, it could take your life. Okay. So again, it's the importance of understanding that you have nothing in your possession that allows you to touch any type of wire that comes down.
Doug, can I just ask real quick, my own edification? Neutral wires, are they covered or not?
No, neutral is generally a bare wire. Most cases it's aluminum, but there is still some old copper out there.
Okay, yeah,
Yep.
okay,
So if it's
thank
running
you.
with, yeah, if it's running with that covered wire, right? If you have two or three energized wires and they're covered, in most cases, you will get the bare neutral that runs right intertwined with it. Underground,
So that wire is not just covering, or it's just not. I always used to think that that wire would is just holding up the other wires, but it's actually an active wire.
it is the neutral, correct. Yeah. So everything that is above the ground is below the ground, right? So we got a lot of underground out there, same way. A big part of my job is damage prevention, okay? And that is 811. I'm not sure on your side. I know the state in a lot of cases is exempt. I don't know if you folks are in the Parks and Rec side, but I still encourage you, if you are going to do any type of excavation within the Park and Rec, simply make the 811 call, okay? And allow facility owners to come out and mark the underground facilities for you. It's very important. Obviously, you can't see it. You don't know how deep it is. We don't know how deep it is. We're asked that often, right? When it's installed at a required depth. For us, it's 39 inches today. And then there's screenings and there's different types of fill. But what happened over time, or even what happened a month after we installed that facility, final grade was performed, and what was a depth of 39 inches could be 29 inches, it could be 19 inches, it could be 4 inches, okay? Because what was 39, final grade happened, and all that depth went away. So be mindful, make the call. It's very important you do it, and it is a law. It's a law in every state to make the 811 call. Fibers out there, we just talk, you and I mean, if you see the strands of fiber, similar to what was there, I don't know if, yeah. If you see these strands that are within there, the only thing we say, we do have fiber on our transmission. It's on the very top, the overhead ground wire, and it's how we communicate between substations. So we're using that fiber to do that. The only thing we caution you on, if you see a wire like this down, don't look into it, right? Because that fiber, you could have those rays still coming through that wire. Pad mount transformers, these for us and for First Energy, this is the best information you can give us if something happens, okay? Tree on the wire, one of these pad mounts gets hit. It happens often. Car backs into it. You're working near it and you bump it off the base, okay, down here. Now you have potential for exposed wires. Just get this 10-digit number. It'll either be an S or an N, depending on where you are within our service territory. and give that to us when you call in 1-800 dial PPL and give us that 10-digit number. The best information you can provide for us tells us exactly where you are, okay? And we can do some stuff before even getting to the scene to make it safe for you. The pad mount transformers, again, today it's mineral oil. And the caution here is if these pad mount transformers happen to get hit, vehicle, tractor, mowing, okay, we see a lot of times you don't even see it, right? You forget it's there and you got the brush hog behind, you swing around and boom, you hit that pad mount transformer, forgetting it was there. The important part here is the connection in the back. This is what's in the oil in the back side, and the connection from 7200, okay, into the back of this is 3 inches from the sidewall. So if you happen to hit that with, again, anything, did it damage it enough that the connection got too close? Okay. And now it's going to energize the side of that pad mount transformer. If you hit it, just call us. Don't try to push it back onto the base because you don't know what happened in the backside or even on the front side with all the connections. Okay. Because if you go to try to push that on and it made contact, again, it could be the last thing you touch. That can happen. Doesn't happen often, okay? But some of these, if they just like an overhead transformer, okay, the pad mounts can do the same thing. If you get a bad fault, then they could explode. I've seen way too many things with these things. People draping tablecloths over them and 4 children sitting around this transformer having lunch. Kid you not, okay? Should never do something like that. These are energized electrical facilities. Submersibles you want to run into, this is more of in a city environment type of thing, but we do have, if you're in a city type environment, you got underground electric, it's a network, and obviously things can fault, right? And if they fault, and if you do see smoke or fire coming out of a manhole, just keep everybody away from it, okay? If those facilities were to explode, okay, for some reason, you got a roughly 300-pound manhole lid that's on top. And if it were to explode, where does that 300-pound lid go? Well, it gets shot into the air, okay? So if you're in that city environment, you see smoke or flames coming out, just get everybody away from it and don't touch it, don't approach it, and make that phone call to us. And well, if you're hopefully seeing it, but okay, that did explode. All right, where did that 300-pound lid go? So understanding the underground and what's out there. Electric meters, all of our meters are what we call smart meters. We no longer have to come out to read the meter, and we can shut that meter off remotely. Okay, if you need a meter shut off because you want to try to do something or there's an emergency situation, let's just say there's a fire of some kind, maybe at one of your facilities. You can call in and ask us to shut the meter off, and it'll shut everything from the meter in off. Okay. Everything from the meter in. Everything from the meter out is still energized. But it helps our first responders, firefighters, and even police officers if they need to get power shut off into a home or business. That's more, I don't think you guys have voltage detectors, but if you do, I encourage you to throw them away because they're just going to get you in trouble, okay? But if you have these type of voltage detectors, a lot of our fire companies do, and for that thing to accurately work, number one, who's responsible for it? When was it last tested? When were the batteries changed? And when you turn it on and it goes beep, 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 What's it telling you? In most cases, you must get too close to the wire that's down before that thing goes beep, beep, beep. Okay, and I'm going to talk about a distance at the end here where I'd like you to be to a down wire. Just the case here where you can see the phase wire up on top of the pole actually came off of that insulator. Okay, so in this particular case, if it does not blow that fuse, will that wood pole conduct? It potentially can. Okay, so storms coming through. Okay, again, this is the importance that stay away. Okay, until your utility gets there and tells you it's safe and it's out and grounded. It's just a case to show you devices don't trip all the time. Okay, you can see this vehicle into this pole over here. Everybody is staying a safe distance away. And this is just continuing to arc, and it's trying to send fault current back to a device. The devices need fault current in order for it to physically trip. But if it's not sending enough fault current back, it won't trip. And it'll continue to do this until a point that what this is doing, it's slowly burning down through the pole until it gets to the neutral, right? Where does electricity want to go? It wants to go to ground. And when it gets to that ground wire, you'll see what happens here. Okay. It got to the ground and ultimately send enough fault current back to de-energize the line. So if you ever come across something like that, the obvious thing, stay away. Okay. It should at some point get to a point where it hits that ground wire and trips out. This is our voltage detector on a tested stick, and we are wearing our PPE to keep us safe. Okay. And we show this because somebody put this barricade right here and had caution tape taped to the wire. And when we got to this situation, that wire was still energized. Okay. Never. Okay. Don't put a piece of caution tape on a tree or on a wire that come down. Stay away from it. By OSHA standards, not ours, OSHA, as a non-qualified electrical worker, you need to maintain 10 feet to all of our distribution voltages, which are 3 wires on top of that wood pole, 1 wire on top. The neutral, remember, you got to consider the neutral as energized. You need to maintain 10 feet to it, as well as the service wire that's coming into the side of a building and or your home as a better example. But if you got a service wire coming into a building on property, by OSHA standards, you are to maintain 10 feet to that wire as a non-qualified electrical worker. 10 feet. Pass through that. And this is just, again, wire down. Okay. Somebody placed cones. Okay. These 2 cones here it should never be that close, right? We should be barricading up on top of the hill and then behind us here a safe distance and barricading that road off, but never walking up to the wire that close to put cones out. Good one for you folks right out within the parks, and you get that tree that comes down. In this case, there is nothing you can do. Okay. Don't walk up, just block the road on both sides. Will that tree conduct? If that wire is still energized, this tree, right, got water and sap in it, and it's attached to ground. And if it doesn't send the fault current back to blow the fuse, this tree is energized. Every step you take towards that tree, you're putting your life in jeopardy. And I'll talk about ground gradient here in a sec. Dump trucks, excavation, same thing. Okay, if you are doing excavation within the parks, number 1, make the 811 call. Okay, let us come out, let all utility owners come out. Red is electric, yellow is gas. The two most important things you want to know where they are before you do any excavation. Pennsylvania, you're not allowed to mechanically excavate within 18 inches either side of the paint that is placed on the ground. Blue is water, green is sewer, orange is communication. Mark your excavation in white. But if you were to dig into energized electrical facilities, remember, you got 2 points of contact here, okay, as illustrated here, right? If you dig into a wire with the bucket, that is energized, okay? The entire excavator is energized, as well as the tracks of the excavator. And it sends that energy out throughout the ground. It's called ground gradient. And the best way I can explain ground gradient is if you've ever thrown a rock in the pond, right? And when that rock hits, what happens? You get ripples in the water, creates rings around where that rock hit. And that is exactly what electricity does. Each ring is a different ground gradient. If you get your feet between two different rings, okay, one ring and the other ring, and you got 1 foot in one ring, 1 foot in the other, you become a human jumper cable. And where does that energy go? It goes up through you to get out the other foot. You complete the circuit. That's why we stress never approaching any wire. Because if it's energized, or in this case, you got an excavator and it's energized, right? It's sending that energy in the ground, creating the ground gradients, and simply stay away. Okay, vehicle. You could get this within your parks, okay? But if a vehicle hits a utility pole, or if you excavate into underground electric facilities, where's the safest place for you to be? And that's in the vehicle, okay? You're safest in the vehicle no matter what happens, okay? Unless it catches fire. If the excavator or the vehicle catches fire and you are what we would call the first responder, it's a residential family coming into the park for whatever reason, they hit that pole and wires come down. Got to understand there's nothing you can do to help those people until the utility gets there and tells you it's out and grounded. Remember, every step you're taking to get to that vehicle, you're putting your life in jeopardy. And when you get to that vehicle, you cannot touch the vehicle or the occupants in it. Okay? Because if you touch the vehicle, or mom that's trying to hand a child out the window to you, as soon as you touch, again, you complete the circuit. Okay? So it's the importance of, it's hard. If something like that happens, you got to stand back and wait for the utility to make it safe.
Hello?
I'm going to let this
Sorry,
one
my
run.
meeting
It's a
ran
pretty
late.
good
Should be home in about a
video
half an hour.
just to talk about this.
Sure, I can pick up dinner. What do you want? Hot and spicy. That's what I'm talking about. I will. I love you too. Oh, man. So that's what an
Oh,
airbag feels like. My car. Great. I should probably get out and see how bad the damage is. Wait. Are those telephone wires or power lines? Either way, they could be hot. There's no way to be sure. Don't take any chances. Just stay in the car and call 911. Good thing I actually paid attention during that safety meeting. Hi, This is Stephen Stonebanks. I've been in a car accident. I hit a power pole. I'm on Highway 18, um, somewhere east of the 356th Street exit, a couple of miles. No, I'm okay, but there are power lines on my car. Okay, yeah, I know. I won't move until you tell me that the line is de-energized. Yes, I will stay put. Okay, please hurry. Thank you. Honey, listen, I've been in an accident. No, I'm fine. I'm fine. I hit a power pole. The car is a mess, but I'm okay. Yeah, I've called 911. They're on their way. Oh, no. Hey. Uh, no, don't come any closer. You could get shocked by the ground around these down power lines. Stay back about 35 feet and make sure no one else comes near. Okay. I've called 911. They're on their way. Thank you. Honey? No, 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 no. I'm fine. No, don't worry. Yeah, the police are on their way. Yeah, all I've got to do now is sit and wait. Honey, I gotta call you back in a couple of minutes. Oh boy. Not good.
Oh my gosh.
Oh, okay. Plan B. Exit the vehicle. But now I gotta worry about touch potential. Touch potential is risk of electrocution based on one part of the body touching an energized object like a car while simultaneously touching the ground. Electricity flows from the vehicle through the body and into the ground, essentially making me into a human jumper cable, which would be bad. I gotta jump and land with both feet together. Now, depth potential. Because the ground is energized, electrical current can travel through me if my feet aren't close together. Electrical current enters through one foot and out the other. The further apart my feet are, the greater my chances of getting shocked. So I must move away using short, shuffling steps. Shuffle, shuffle, shuffle. There you go. You got this, Stephen. No large steps. Just keep on shuffling. Every day I'm shuffling. I'm sorry, I can't come to the phone right now. I'm busy trying to stay alive at the moment. Almost there.
Okay, so I don't know if folks know that or what to do in that type of situation. What I have learned over, I've been with the company almost 37 years, and what I have learned is our teenagers do not know what to do in this situation. So if you have youngsters, teenagers that are about to drive or will be driving soon, on our website, pplelectric.com/safety, we have a driver education page. And in there, you can actually print glove box cards right off the website and review that with your kids. Again, they stopped teaching it in school. When I was in school, we had driver ed, and that was one of the things they talked about, but they're not teaching it today in school. So understand and review what to do in those types of situations. Small amount of electricity it takes to actually injure us or potentially kill us. And you'll notice here, it's anywhere from 50 to 100 milliamps. Milliamps, 1/1000th of an amp, okay? And we talk about, in this case, is a receptacle, okay? Did you ever try to replace a receptacle and decide to do it hot, okay? And you get shocked, right? A dining room receptacle, probably controlled by a 15 amp breaker down in your panel box. And if you thought, we can do this, we don't need to shut the breaker off, pull that receptacle out, unscrew those two screws, and for whatever reason, the wires crossed and you got shocked. At that point, when you got shocked, changing a dining room receptacle, you potentially had 15 amps of fault current go through your body to go back and try to trip that breaker down in the panel box. It only takes 50 to 100 milliamps to stop our heart, potentially taking our lives. Household current takes the lives of more people every year than our overhead distribution facilities do. So if you're going to do work in a home, okay, simply walk down the steps, open it up, and shut the breaker off. I shut the main off, okay, because somebody scribbled dining room next to that breaker. And did they scribble dining room next to the right breaker? All right. But tester, right? It's a $10 tester. Stick the two little leads into the receptacle. Make sure you got the right one and shut the right breaker off before doing work on it. Okay. Small amount of electricity it takes to injure us or potentially kill us. Flows through anything, your body, trees, guardrail. If you happen to have the guardrail, guide rail, okay, and there's a wire down, it can energize that guardrail for a long distance, okay? So if you have those out there, again, you need to widen, okay? They said 35 feet if you heard that in the video, okay? My recommendation is one pole, okay, away from where that wire is down or 100 feet, because I can't tell you how far that energy is going to go through the ground until it dissipates. It all depends on the ground type, the soil type, how much water is in the ground, okay? I recommend one pole away and or 100 feet. That's where I'd like you to be from any type of down wire. Substations wouldn't involve you folks. Ultimately, what's inside of there, okay? Ultimately, when it gets enough fault current, it will ultimately explode, okay? And pretty catastrophic. Stand back, watch it burn, okay? If there is one close to your facilities, don't approach it, keep everybody away, okay? Make sure 911 is called. Okay. I tried to leave a little time for questions here. This is a trailer that we utilize to educate first responders, contractors, and the public. We take this around all 29 counties that we serve in Eastern PA. First Energy does have these. They built one for every operating company. If you happen to be within First Energy, reach out to them. We actually energize this trailer to 7,200 volts. And everything I talked about here today, we're actually able to show you with energized electrical facilities. So it's a little more impactful when we can do this presentation with our exhibit. We do a little over 100 presentations a year with our trailer. We have one tonight in the Bath area. If you happen to be near Allentown and or Klecknersville Fire Department, north of or west of Bath, we're going to be up there tonight at 6:30. So downwire, treat them as energized. You have nothing in your possession that allows you to touch any wire that's down until your utility gets there and tells you it's out and grounded. If you're doing work with trees and that tree falls on the line, let it there. Make the call to the utility, and the small amount of electricity it takes to injure us or potentially kill us. 50 milliamps of electricity could potentially take our life. I forgot to mention, how do I put 50 milliamps into perspective? If you have a night light bulb in your bathroom or a child's bedroom, that night light bulb is a 7.5 watt light bulb. That 7.5 watt light bulb draws 62.5 milliamps of electricity. A night light bulb, if the conditions are right, could actually take your life. So hopefully you got a little something from this. It's about education, and we're trying to keep you folks safe and doing what you do out there. Um, Again, the key points I just touched on there, I feel are the most critical for what you folks do. So with that, Dan, I'll turn it back to you. And I see one thing in here from Mr. Albright. Are the neutrals always just below the fuse box? So the neutral is directly below the transformer that's on the pole. So that gray canister that's up on the pole, the neutral will fall right below that transformer on the pole.
Well, Doug, I'm shocked. Uh, it just a lot of information, and I really didn't know anything about the whole car thing and how to navigate that. So, thank you for that. I'm going to share that with my kid as soon as I get home.
Please do. And
Really
again,
good information.
yeah, on the website, our safety website has first responder contractor kids. There's a great kids program on our website, and now again we have a driver education program. So three good things on our safety website. Please look them up.
Okay, I'm going to start the questions off because I do have a few. One is sort of just I've always wondered how do birds and squirrels get away with running all over those lines and not getting shocked? And then the second one, the more important one, is when you're working around power lines, like where does what does the law 811 come in, and when you also mentioned PA Act 127. Can you tell me like a little bit more about those laws and how they might affect people in our field?
Sure. Yeah, so animals, they impact our system every day. So that squirrel can run out across that top energized wire. It can run across that service, okay? Because it's essentially I could stand on the top of that wire energized as long as I am not touching something that puts me a path to ground. It's like we work from helicopters, okay? So we can energize ourselves and the helicopter to the same voltage, and we can do work because we're not a path to ground. It's not until the squirrel is touching an energized wire, like sitting on top of the transformer, the biggest one that happens for us. Get up on top of the pole, on top of that transformer, and they're sitting there. On the top, you have a bushing, and on the top of the bushing, it's energized. And all they have to do is the fluffy tail touch the top side of that bushing. They're sitting on the transformer attached to the pole set in the ground. They become a path to ground. Blue sky day like today, 99.9 times out of 10, when we get to you, we're going to find the squirrel at the bottom of the pole. And because they became a path to ground. Otherwise, as long as they're just running out across that wire, it's called a Faraday cage, right? You're the same potential.
Okay.
811. Yep, Act 127. So I actually sit on the board of directors for Pennsylvania 811. And so anytime you are moving earth by law, you are required to dial 811. Now, I think I mentioned the state in certain cases is exempt. Okay. And there are some exemptions in the law for work that the state is doing that is not deeper than 18 inches, does not require a one call ticket. Okay. Um, but again, I don't know if you fall into that exemption with what you folks do. I would encourage you to find out. Um, but it's just a good practice. Okay. You, if you become a member, it costs $125 a year. That's it. Okay. And you can place one or you can place 10,000 one-call tickets in that year. Okay. And anytime you are going to move earth, except with a shovel, hand digging, it's not required. But again, I highly encourage you to simply make the 811 call. We have 3 business days to come out and do that marking. So if you place a call on Monday, that means Monday does not count. We have Tuesday and Wednesday to come out and mark. You are lawful and legal to dig on Thursday. So 3 business days. You place one on a Friday. Friday doesn't count. Saturday doesn't count. Sunday doesn't count. We have Monday and Tuesday to mark. You're lawful to dig the following Wednesday.
Great. All right, I'm going to open it up. Anyone else have questions? Please feel free to unmute yourself. That's the little microphone icon in the bottom there. Just click on it, unmute yourself, or you can leave a question in the chat box. All right, I'm hearing crickets. I do want to thank Becky Richard, who's on this meeting. She was the one that told me all about you guys and your. I guess you did a presentation at Penn College, and learned a lot. And we're actually working on having Doug and his crew come out for our next conference at in the Poconos there next year. So we'll see what we can do. We understand that they have to be outside and there's some things to take care of, but we may very well get that Penn Electric, that PPL demonstration area set up. Okay. If I'm not hearing any questions, I think they're all juiced up, so to say, with all the answers, and they can light their way home. And I'll stop using those puns. And oh, we have one. Oh, a thank you from Judy. I'm sure, Doug, it was great, very informative. And really, thank you so much for doing this. Again, this will be recorded and posted in the tool shed, and we'll make this available to other people to watch at their when they can. I encourage everyone to go to the pplelectric.com site and look up driver safety. I thought that was really, really interesting. I had no idea. If you had idea, some idea of all that before that, congratulations, but that really took me by surprise. Okay, everyone, I'm going to end this here. I'm going to end the recording now. Well, I'm just going to end everything. I hope everyone has a great day. And once again, thank you, Doug.
You're welcome. Thanks, everybody. Stay safe.
Bye now.